today I am going to perform and discuss to you on how to solve complex numbers using the MATLAB application. So let us start. So first and foremost, in doing this, we need to have a MATLAB application in our laptops or in our smartphones or any devices that we will use in this activity. So let us first open our MATLAB application. So I have opened here already my MATLAB application. And in this, in the menu bar here, we have to click the new script. So if we click this new script, this will appear here. And then to save our output or file, we need to click this save button or click save as, and then name it with the name that you want. MATLAB Lacumbo 224 and then we will now perform the conversion of complex numbers using a series of codes. So we have here codes that we will type, and then we'll run it, and it will show some outputs. So let us start. So this group of codes that we will type first is it will convert the rectangular complex form into polar form. So we have here our problem, which is 3. This is the problem, 3.12 minus j square root of 3. So this is our problem, and we'll erase it. So this is the real start of our code, which is we will type first the rectangular form of 3.12 minus j square root of 3 save to z. Z equals 3.12 minus j square root of 3. Let us don't forget the semicolon. So we will enter, and we have new line. And in this part, we will type the real component of z, which is a equals real parentheses c semicolon. The next one we're going to perform is the imaginary component of z, which is b equals imag semicolon. And in this part, or the fourth line of our code, is we will perform the modulus a of the polar form of z, which is a equals square root of a squared plus b squared semicolon. And next is we will type the argument theta of the polar form of z. Theta equals b over a semicolon. And at this point, this is the last line of code in this group of codes, which is str join polar form num since this is the last part of this code, we will press the run button to see if there's anything error, and at the same time to show the output. So that's it. We have here the output, and it means that there's nothing error. There's no error here in this code. So this is the output. And so that's it. And to perform another series of codes, we will just highlight this codes and press the Control R. And that's it. Enter, enter. So we need to have separating space so that we can identify which is the end and the start of each group of codes. So at this point, we will type different code using cart to pull and cart to pull function and compare it with our previous result. So the first line here is determines the data and A using the cart to pull. Semicolon. So another line of codes is it converts data from region to degrees. So this is the code. So data equals 1 to data semicolon. And now this is the last part of this code, which is str join. So this is our second group of codes. And now we will press the run button to see if there's anything error and at the same time to show the output. So let's run it. So have shown an output which is polar 3.568.685 is greater than negative 29.0366. So and let's compare it with the previous one. So as you may have noticed, the result or the output of the previous code is the same to the result of our recent code. And now now we will perform the reverse. So using the same values of A and theta from the previous codes, we will highlight our previous code and we'll press the Control R. So here it is and enter. And now we will type the code below to convert it back to rectangular form. And this is the first line of this code, which is we will type the real component of Z. A equals A. There is cos B theta. And for the second line of this code, we need to type the imaginary component of Z. B equals A asterisk sine B theta semicolon. And in the third line of our code is we need to type the rectangular form using complex functions. So we need to type Z equals complex parentheses A B and semicolon. And this is the last part of this code, which is str join parentheses curly bracket rectangular form str Z. And this is the another set of codes. So since this code is done, we will just press the run button to see if there's any error, and at the same time it to show the output of this code. So there's no error, and at the same time it have shown the output, which is here, rectangular form colon 3.12 minus 1.7321i or imaginary. And since this code is done, we will highlight it and press the Control R and enter new line, and type different code using call to cart function and compare it with our previous result. So the first line of this code is it converts data back to regions using deg to grad. So this is the code, which is data equals deg to grad and data semicolon and enter for a new line. And this code determines the A and B using call to cart. So this is the code. A, B equals call to cart data A and semicolon. So at this juncture, we will type the rectangular form using complex function, which is z equals complex A, B, semicolon. And then this is the last line of this set of codes, which is str join rectangular form str c. So this is the so we are done with this code, and now we will press the run button to see if there's any error in this code and to show the output in the command window. So it have shown the output means there's no any error in this code, and the output here is rectangular form colon 3.12 minus 1.7321i or imaginary. And let us compare it with the previous code, which is the same. This code here and this code have the same output. And so since we are done with this, we will highlight this code and press Ctrl R and type again another set. So that's it, and at this point we will perform few examples. So our first example is 3 plus J4, and the codes that we will use is the first and the second set of codes. So let's have first this first set of codes. So our problem here is 3 plus J4. So let us see if the code has no error, and if this code has output. So let's try to run it. Oh, so this is the output, and it means that our code has no error. And now let us highlight this one and press Ctrl R and another line. And at this time, the second set of codes is we will use the second set of codes. So let's try to run this. So it's also the same with the previous one. Let's highlight and then Ctrl R and add new line at this time. So our next problem is 13. This is Gora form, which is 13. Okay. So this is in plural form. And now we will use this third set of codes. So first we will set, let's add the value for our z, which is 13. Okay. So in this we will just specify our a and our theta to run this code. So our a here is equal to 13, and our theta here is 67.30. So let's try to run this code. So as you can see, there is no error in this code, and we have an output which is 5 plus 12i or imaginary. We will perform the last set of code, so let's highlight this code and Control R. So this is the last set of codes. Let's again put the values of a, which is 13, and the theta, which is 67.38. Let's try to run this one. So it's also the same with the previous one, and it has an output of 5 plus 12i. So this is correct answer. So at this point, let us again highlight this code and Control R. And now this time, we have two complex numbers, and we will try to find its sum, its difference, its product, and its quotient. So let us first find their sum and difference. So the problem here, or the two complex number here, is for z1 2.3 plus j 6.5, and for our z2, which is 1.4 minus j 0.86. So this is our complex numbers. I have here already prepared. So this is the code for the first complex number, and this is the code for the second complex number. And this here, the code here is for their sum, to calculate their sum, and here is to calculate their difference, and here is to display their sum, and here is for display their difference. So let us try to run it if there's any error, and if the output will show. So this is their sum, and this is their difference. So let's try to type it below them. Their sum is negative 0.9 plus 5.64 I 5.5 J 5.64, and their difference is negative 3.7 plus 7.36 I, or rather J 7.36. And now we will perform the multiplication and division. We will highlight this code and Control R. So firstly, in this set of codes, we will type the value of z1, which is negative 2.3 plus j 6.5 colon, or z2 equals complex 1.4 negative 0.86 colon, and now for product, which is z1 times z2 colon, and for quotient z1 over z2 colon, and product. So let us try to run this one if there's any error and if the output will show. So as you can see, the output is not here but instead here. You can see the product and the difference. The product and the quotient. So their product is equals to 2.37 plus 11.07 or 09 or 08. I mean J times 11.08. And for their quotient, which is negative 3.26 plus J times 2.64. So this is their product and their quotient. So that's all.